Okay, this is 3.6 rational functions. It says a rational function is in the form of p of x over q of x, where p of x and q of x are both polynomials. Okay, I've given you the parent function, which is 1 over x, and we're going to graph this just to kind of review you of it. It says as x approaches infinity, your function approaches 0, and as x approaches negative infinity, your function also approaches 0. And what this is showing you right here is your horizontal asymptote. I'm going to abbreviate it HA. So your horizontal asymptote right here would be y equals 0. As x approaches, what this represents right here, 0 from the positive direction. So if you come about it this way, 0 from the positive direction, what is your function approach? So what I would do is plug in a number like 0.00, So what happens to this number is that 1 over 0.0001 is going to get really big. It's going to go towards infinity. As x approaches 0 from the negative direction, your function approaches, so going from this direction, so I'd do the same number, just go negative direction. So it'd be a negative number. Then your function approaches negative infinity. And so what we just came up here is your vertical asymptote. And that is going to be x equals 0. Okay, if you don't remember what this function really looks like, it was the one that was in the first quadrant and in the fourth quadrant. And I'm going to plug in just one number to kind of guide us. So if you plug in a 1 here, 1 over 1 is 1. And it's going to go towards your both asymptotes. If I plug in a negative 1, that gives you a negative 1. And again, it goes towards both asymptotes. So that's your parent function. Just to throw something in here is your domain. Your domain goes from negative infinity. It skips your asymptote and it picks back up. And your range looks like it's going to be the same thing. So, all right, when x equals a is a vertical asymptote, if as x equals a from the right or the left, your function is going to approach infinity, or it could approach negative infinity. So that means that your f of a is going to be undefined. If y equals b is a horizontal asymptote, if as x equals positive and negative infinity, then your f of x is going to approach your b value. It says your end behavior, or EB, and your horizontal asymptotes are essentially the same thing. And we're going to get into more of that as we get more into this lesson, some graphing. Okay, so finding asymptotes. It says the vertical asymptote are the lines x equals a, where a is a 0 of the denominator. So it says horizontal asymptotes, and again, I'm abbreviating these, vertical asymptote and horizontal asymptote. Horizontal asymptotes follow 3 rules according to the degree of the numerator. Remember, the degree is going to be the biggest exponent. Okay, so out of our 3, it says if the degree of the numerator is smaller than the degree of the denominator, then the horizontal asymptote is always, always, always y equals 0. And I always call this one bottom heavy. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote equals a over b. And what that means is that we're going to do a ratio of the leading coefficients. Okay, for the third one, it says if the degree of the numerator is greater than the degree of the denominator, then there is a slant asymptote. We're calling that SA. We will have to do division. Most of the time, you're going to have to do long division, but sometimes we will be able to do synthetic. Okay, and my little saying for this is that we are top heavy. It says you may have one or more vertical asymptotes, but you will only have one horizontal or a slant. You can't have both. Okay, it says find all asymptotes of this function right here. Given this one right here, the first thing I would probably do is find my horizontal one. And I would find that because you can find out if it's top heavy, bottom heavy, or if there is a ratio. And I'm looking at my biggest exponents and they're equal. So that means I do a ratio, and my ratio is going to be 3 over 2. So you're going to write y equals 3 over 2. All other asymptotes would be vertical asymptote. To find your vertical asymptote, what we need to do is factor. And remember, you find your vertical asymptotes from the bottom. So let's go ahead and factor. And then we need to practice, so let's factor the top and the bottom. You can go ahead and group. Practice this. I got 3x plus 1, and I got x minus 1 on top. On the bottom, I got 2x minus 1 times x plus 2. Now, in this case, if I were to have something on top and the same on bottom, I would cancel it out. That would cause a hole in your graph. Okay, since I don't, I'm just going to take my bottom and set them equal to 0. So this would be x equals 1/2 and x equals -2. So those would be my vertical. All right, and there are my 2 answers. Okay, now let's go ahead. You picked up a paper in class today. Explains this right here that I'm about to talk about. Frady. Find everything in order to graph a problem. So the first thing that Frady says to do is to factor. And factoring helps you find any holes in your graph as well. And these are called discontinuities. Okay, so I'm going to factor this. And if you're having trouble factoring, make sure you come in and get help. So this is 2x minus 1 times x plus 4 over x plus 2 and x minus 1. Since none of these are exactly the same, we're not going to cancel anything out, and there's no holes on this graph. To find your roots, this means we have already been finding our roots. Those are your x-intercepts. So you're going to take your top and set them equal to 0. So I'm going to call these my x-intercepts, and I'm labeling as I go. So my x-intercepts, I'm going to write them as ordered pairs. So this would be 1/2. So this would be 1/2 and 0. My next one would be -4 and 0. On your Rady sheet, it tells you how to find asymptotes, and we've done that. Vertical asymptotes is to set your bottom equal to 0. So vertical asymptotes, setting the bottom equal to 0, would be x equals -2 and x equals 1. And those are equations. Number 4 says 2, identifying any multiples. That would be finding your end behavior. I have no multiples of 2, so I'm not going to be bouncing back like this and finding any parabolas. Okay. Our horizontal asymptote now with my end behavior as well. I've got a squared here and a squared here, so they're the same. So that means I need to find a ratio, so my ratio would be 2. So y equals 2 would be my horizontal asymptote. Is my y-intercept. That means my x value is 0. You can plug in an x value here, or you can plug it in here, whichever you think is the easiest. I think it's easiest to plug in here, honestly. So if I plug in an x value of 0 here, that cancels. I have -4. 0, 0, and I have -2. So -4 over -2 gives me a +2 value. So 0, 2. So now all I need to do is start graphing everything. So vertical asymptotes, remember up and down, so I have at -2 and at 1. My horizontal asymptote is at 2. My x-intercepts are at 1. Y-intercept of 0, 2. It looks like it's right on the line. Remember, you can cross horizontal or slants, but you cannot cross verticals. Okay, so I have everything set up now. And so now I just need to figure out what the heck and where this is going. It looks like right here that these two are going to connect. So I'm just going to connect these. If I were to guess, I would guess this goes down and follows this asymptote. They usually do follow the asymptote. Remember I talked about how there's no double, so I'm not going to have any U figures right here. Okay, if you were unsure, the easiest thing to do is to go ahead and plug in a point. If I didn't know that, I would plug in a point. Okay? Now, remember, I don't have a U, so there's no way this is going to come back. This has to go and follow this asymptote right here. Now, because I have no U figures, right here, this x equals -2. Because it is not a squared, this 2 right here, identified multiples of 2, x equals -2 is not squared. Therefore, this is I'm going to have an opposite arrow. That means if this went up right here, on the other side, it's going to be down. It's always going to be opposite. Therefore, I know that I'm going to go through this and follow the asymptote. Okay, again, over here, because my x equals 1 is not a squared, because I went down here, I'm going to go on the opposite side, and I'm going to go up. And I'm going to follow these asymptotes over here. And I don't even care about any points. I'm going to follow it. Now, we'll tell you this. When you're going across your graph here, you're going to have a graph in each section. So I have a vertical asymptote. I've got a graph over here. I've got a vertical asymptote. I've got a graph, vertical asymptote, and graph. If I were to put a graph up here, this would not be a function. Same down here. I can't have a graph up here and down here for it to be a function. Okay, let's try another one. So, following Frady, the first thing it says to do is to factor. So I'm going to take this and factor first. So this would be x minus 5, x plus 1, over x minus 3. Nothing cancels, so I'm going to move on, sorry. I factored. The next thing it says to do is to find your roots. That's your x-intercepts. Now you can go in a different order. I'm just trying to follow that Frady. So that's going to be 5, 0, and that's going to be -1, 0. I'm going to go ahead and label y-intercepts, but I'm not going to use it yet. Okay, next thing it says is vertical asymptote, so x equals 3. Frady then says to do end behavior. That would be that would be your horizontal asymptotes. So horizontal asymptote, looking at this, says top heavy. So I'm not going to have a horizontal, I'm going to have a slant. How you find your slant, remember I said you divide. So I can take my original problem and do long division, or you can do synthetic. So since I just have an x minus 3, I'm going to do synthetic. So I'm going to use a positive 3. I'm going to use a 1, -4, and a -5. If I bring this down, that gives you 1, 3, -1, -3, and -8. Remember, this is your remainder, your constant, and this is your x value. The good thing about this is I could care less about the remainder. I only care about this right here. So my slant is y equals x minus 1, and that's all I care about. Okay? Now we need our y-intercept. Remember, you plug in a 0, and I think it's easiest in this in the original. So that would be a -5 over -3. So this would be a 0 and 5/3. Okay, now we need to graph this. And you can start with anything you want. I like to start with verticals, and so that's a vertical at 3. I have a slant at x minus 1. Now this is just a linear equation. So you start at -1, and you have a slope of 1. So this would be right here. X-intercepts at 5, 0, at -1, 0, and I have 0 and 5/3. Okay, remember there is no squared values, so anytime you see a vertical asymptote, my arrows, they're never going to meet each other. They're always going to be opposite. So I always go to my points and see if I can connect any of them. So like these I can connect, and I would probably say this is going to follow the asymptote. Again, if you're not sure, pick a point and plug it in. Where would that point fall? And it's going to fall up here. So that means that this is going to follow this asymptote up. Okay, because I have an arrow on the left side of my x equals 3, I'm going to go on the opposite side and go down. That means this is going to go through this point, and it's going to follow the asymptote. Again, from my slant asymptote, I have an arrow on the bottom and opposite directions. Okay? They're not going to meet because I have no squared values. Okay, let's try another one. So this is factored and this is factored. Usually you can see if this factors. There's no reason to do quadratic formula on it. Let's go ahead and find our roots, which is the x-intercepts. So my x-intercepts are the top. That's going to be a -1, 0. Since this doesn't factor, that's the only one you have. Y-intercept, I'm going to label. That's going to be 0 something, right? You've got a vertical asymptote. That's going to be the next thing. You take your bottom and set it, so that's going to be x equals 2. Your horizontal asymptote. Okay, what you need to do here is I know I've got an x and an x squared over x, so it's going to be top heavy. So that would be a slant. I'm going to go ahead and multiply this out. When you multiply this out, you get x cubed minus 2x squared plus 3. That's going to make dividing this a whole lot easier. And since this is just a x minus 2, I'm going to do synthetic again. So this is 2. Let's see, this is a 1, a -2. I'm going to have to do a placeholder and a 3. So this is 1. Your slant asymptote is going to be x squared. Find our y-intercept. So let's plug in a y. This one's going to be easier. If I plug in a 0 for my x values, that gives me 3 over -2. So that's -3/2. And let's see what this graph looks like. So I have x equals 2 for my vertical asymptote. I have a -1, 0, a 0, -3/2 there. And I have a slant asymptote of y equals x squared. And again, make sure you really plot this. Okay, so there are your two asymptotes, which looks really strange to me. Okay, so let's graph and see what we've got here. So I've got these 2 points. If I were to guess, I would say we're going to go down like this. Okay, because I went down at the x equals 2, then on the other side of x equals 2, I'm going to have to be on the other side, which is up here. That means I'm going to have a really small graph up here. Because remember, you've got to cover each part of the graph. Okay, so I cannot have anything in this area or it will not be a function. So what I need to know here is what's going to happen with this line. Is it going to follow up here or is it going to go out? That's what we need to know. So what I would do is probably plug in like a -4 into this to kind of see what's happening. It looks like it's just kind of going up in this direction. Okay. Let's try one more function. First one says factor, and it's done. Now, look what happens. X plus 2 and x plus 2 cancels out. That means that we have a whole. Our first one. We have a whole, and it's going to be at, because it's in parentheses, it's going to be, first of all, at -2. So what I want you to do is I want you to plug in a -2 into these numbers to see what the whole is at. Whole is at -2, 5. And I got it from canceling out this function. Okay, the next thing says find your roots. Remember that's your x-intercepts. We're going to go, now we're just back to where we are. X-intercepts, y-intercept, and so on. Okay, x-intercepts, 3, 0. And I got -5, 0. Vertical asymptotes. I got x equals 1. The next thing would be your end behavior, so that would be your horizontal asymptotes. And now you have, no matter if you use your x plus 2 or not, you still have a new function, and it's top heavy. So you have a slant, and I know y'all are so excited to do another slant. But how about we go ahead and multiply this out? This is going to be a x squared plus 2x minus 15. And that's over x minus 1. So again, I can use synthetic. So I'm going to say 1 into 1, 2, and negative 15. So this is y equals x plus 3. Okay, your x-intercept, your y-intercept would be 0, 15. Plug in a 0 value there. Okay, let's graph this one. You have a vertical asymptote at 0, 15, 3, 0, negative 5, 0, x plus 3, so you're going to go up 3, 1, 2, 3, and then you have a slope of 1. Okay, the one thing I've left out is the hole at negative 2, 5, so go over negative 2 and up 5, and this is the way you graph a hole. You just put a big open circle. Okay. All right, this one's pretty clear. It looks like you're going to do this. Go through the hole, pick back up, and follow this asymptotes down. At 1, I still haven't hit any squares. So at 1, since I am up here on 1, I'm going to go down here on the opposite side, go through that, intercept, and keep following the asymptote. Okay, bring questions to class.